Alright, so today we're going to do the Azo Dye lab. We're going to make a diazonium salt with sulfonylic acid. And we're going to then combine it with a little bit of 2-naphthol in order to give us the final orange dye that we're going to be making today as our final product. So what we're going to start with is a little bit of the 25 milliliters of sodium carbonate. We're going to just take 25 milliliters of that and put it into this beaker. Normally the procedure calls for an Erlenmeyer flask, but we didn't have any lying around that looked clean enough, so this will work perfectly well. Just something that you can heat in is all you need. So 25 milliliters is about half of this. Awesome. And I'm just going to place this in the beaker. And then I'm going to go over to the scale, and I'm going to grab myself a spatula. So the next thing that we're going to add to this beaker is we're going to weigh out about 2.4 grams of the sulfonylic acid. Sulfonylic acid is just an organic compound with an aniline and an SO3H group, a sulfonic acid. So 2.4 grams that we want. It's going to be a pretty big heat. This is the macro scale procedure. A little slower. So we're going for 2.4 grams, getting pretty close. Oh, cool. So we have a little bit more than 2.4 grams. So just make note of that in your lab notebook. In case this was, let's say, the limiting reagent, you want to make sure that you adjust your theoretical yield. So 2.48 grams. Carefully. Don't want to lose any of it, causing further deviations. You want to get that all dissolved. Alright, so let this sit here for a second and added a little bit of heat to it, but mostly it dissolved all on its own. And now we are going to, in the meantime, weigh out some sodium nitrite for mixing into this once it actually fully dissolves. I'm going to grab this new weigh boat and zero it out. And then we need 0.95 grams of the sodium nitrite. So let's see what we can do there. It's kind of chunky. Hopefully we won't get too much. Definitely don't want to spill this stuff. It can be pretty nasty. Well, if it's a little bit more, then that's fine. Just make note of it in your lab notebook. So we were aiming for 0.95 grams of this sodium nitrite, and now we have about 1 gram. So make sure you give this a stir. Looks like it's still dissolving a little bit. So you want to make sure you let everything heat to fully dissolve before you go to the next step. So we're going to call a couple minutes on that one. Alright, so we've let this heat up to dissolve, and it's a little warmer than room temperature, so it's probably fine to add the sodium nitrate. So I'm going to carefully place this right here on the bench, make sure I have some clear space, and just add the sodium nitrate slowly. You want to make sure that you get as much of it in there as you can. Try not to waste any of it. And right as soon as you add it, it turns like a deep brown color. Cool. Well, so what we're going to do now is we're going to take this mixture and pour it into some pre-weighed ice and hydrochloric acid. And I'm going to get myself 15 grams of ice. Doesn't need to be perfect, it just needs to be close. Ooh, there we go. 14.93, I'm pretty proud of that. Give myself a little bit more. More is more when it comes to this kind of stuff. Oh, 16, that's totally fine too. Just an extra milliliter of water. All right, next we have to get some concentrated hydrochloric acid. So in order to do that, we're gonna have to get one of these graduated cylinders and retrieve that from the hood directly. It's not very safe to keep it in this hood with everything else, so it's over here in the acid hood. So we want 2.5 milliliters here, but if you have a little bit more, a little bit less, it won't matter too much. Just do your best to get as close to 2.5 as you can for consistency's sake. Just gonna leave this here. I'll come clean it later. And definitely put the lid back on the hydrochloric acid. It is 12 molar and you do not want to leave it open. All right, so now we're just going to take this hydrochloric acid and place it into this beaker. With the ice, mix that around. Remember, you always want to add acid to solutions of water, and as soon as this ice hits this beaker, it starts to melt, so definitely don't do it the other way around. I think bad things can happen. So just good practice. Then we're going to take our mixture of the sulfonilic acid and the sodium nitrite, and we're going to throw that right into this, just adding a little bit at a time. I'm going to rinse this with a little bit of sodium carbonate solution. Just a splash. And the solution is already quite orange. Now it's ready to be mixed with the 2-naphthol. So what you can see here is that although at first we didn't have precipitate form, the precipitate finally gave way as the solution began to form that azo salt, and we have some of that white precipitate leaving the solution, and the supernatant is a light sort of yellow-orange color. Now it's full of that azo salt haze, which is what we want. You want to make sure that this precipitate fully forms before you mix it into the next step. Otherwise, other side reactions that are less desirable could take place, which is not what you want. Alright, so we let this sit for a few minutes, and it has precipitated out into some nice fine crystalline azo salt. So I just need 1.8 grams of this for the next step. And I'm going to dissolve it in some 3 molar sodium hydroxide. The reason that we want to use 3 molar sodium hydroxide is you want to activate this towards being a nucleophile, and it's going to attack the azo salt once we combine the two of them. So 1.8 grams is what we want here. Stuff smells like fish food. Or actually, I don't know, it's kind of like a mixture of old crayons and fish food. Alright, so once we deprotonate this, it'll be ready to act as a nucleophile, so we're going to need 10 milliliters of pre-chilled sodium hydroxide. It's 3 molar, so it's quite basic. And you want to make sure that you get this somewhat dissolved. It takes on a sort of a dark brown color. So we're going to stir to dissolve this. And wait till it's mostly dissolved before we actually combine with the azo salt. So while we're waiting for the mixture of sodium hydroxide and the 2-naphthol to fully dissolve. It took a little bit longer than we thought. I'm going to get the sodium chloride ready for adding to the mixture to salt out our final product as a precipitate. And the way out about 5 grams. This doesn't need to be perfect. This isn't going to affect the yield at all, other than maybe helping it salt stuff out. 5.03 grams. And so what we'll do is we'll just set this aside for now. And it appears that all of our naphthol has fully dissolved, giving us this brown solution of the 2-naphthol, 1.8 grams, and about a little over, I added some more, 10 milliliters of 3 molar sodium hydroxide. So you have this basic solution right here, and that's going to be our nucleophile. And then we have our electrophile in the form of this precipitate salt here. And what we're going to do is we're going to combine these two in order to get our final product in this flask. So here we go. So I'm going to start stirring this. Turns into a dark, kind of almost scary bromine-like red. So we will let that mix. In the meantime, I'm going to get a wash bottle full of DI water just to rinse this into the solution. Don't want to lose any of our products that way. As you can see, it's quite a dark solution, so you definitely don't want to get it on your clothing. It's not coming out. Then we got all of our salt into that mixture so it all reacts. And we're going to let that heat for just a second in order to make sure it fully reacts. If you take a close look, it looks quite dark, almost like a red. Almost evil, like an evil hue to it. So it appears that we've already mostly dissolved this Azo Dye. It's really hard to tell because it's quite concentrated, but you can see that it's very dark, but it's very homogeneous in terms of its texture. So what we're going to do now is that we're going to take some of this sodium chloride that I weighed out, about 5.03 grams of it, and we're going to just add that to help salt out the product. What you might notice right away as soon as you add that sodium chloride is it becomes a little bit chunky, and that's because you're already taking a pretty insoluble compound that is not that interested in sticking around in water, and you're making it even less soluble. And so we're going to let that heat for a second, try to dissolve as much as we can. And then we're going to throw it into this ice in order to precipitate it out. Just another recrystallization. So it started simmering and bubbling a little bit, and it's pretty opaque. It's quite dark. So I'm probably not going to worry about making sure it fully dissolves here. It's just impossible to see anyways. So what I'm going to do is I'm going to take this hot solution and I'm going to put it on this ice bath and allow it to cool. So that's going to allow this to precipitate, and hopefully most of it will fall out of solution, and that will leave us with as much product as possible for the filtration step. Whenever you do these filtrations, it's good to start with product that's been especially well cooled because it'll be less soluble and you don't want to lose any product into your filtrate. You also want to always add water to your ice baths just to make sure you get maximum surface contact with the edges of the flask. If you want maximally crystalline product, always crystallize slow and crystallize as dilute as possible. If you want good crystals, if you want maximum product, get it as saturated as you can and just do your best when it comes to slowly
cooling it and allowing stuff to fall out of solution.
Alright, so we have taken this product and we let it cool and actually solidify. The entire solid this entire mass here is all solid. So I think that we probably have some extra water in there. It usually takes a longer time to dry. This product loves water. But that's fine. We have a vacuum filter, really good for that. So the way that you're going to use this vacuum filtration apparatus, this is a Buchner filter, is you're going to take a filter paper and we're going to pre-weigh it. So I'm going to just place it on, this is pretty thin, it'll be fine, on the scale. It's about 0.32 grams, 320 milligrams. And it's a little bit of water that I got from my hand on there. I'm just gonna put it in place, turn on the vacuum, and I'm going to take a little bit of DI water to help improve the suction. So apparently this vacuum is really good. You can actually feel it on your hand a little bit if you cover the top. So that way you know you're ready to go. Next, we're going to take this, and since it's just a full solid, just a hunk in here, I'm going to mix it around a little bit. It's just like sludge. And I'm going to see how much of it I can spoon over into this orange sludge. And try to aim for the middle of the filter paper here. That will yield you the best results. It's just like, I don't know, gravy or blood pudding. It's pretty nasty. But it shouldn't be able to get through our filter paper, so we will collect the product this way. So if you're going to wash this product, and by that I mean if you're going to rinse the stuff that you just placed into the top of this filter here, which can take a little while, you're going to want to make sure that you use a solvent that is not going to dissolve it well. So I'm going to take about 20 milliliters of saturated sodium chloride solution. That's coming pretty well right there. And I'm going to eyeball, that's about 20 milliliters. Look at that, that is just something else. Now it's good to make sure that you keep an eye on the filtrate, just to make sure that it doesn't get up into the vacuum line. Otherwise, you could make your lab manager very, very angry. It's not a very easy thing to clean up. And it definitely is not going to come out if it gets anywhere other than into the waste container. It's a dye. It's a very concentrated pigment, and it will color that thing forever. So, luckily, I mean, if you're trying to use it as a dye, it's good at its job. It's definitely good at staining things. Alright, so I'm going to see if I can get a little bit more of this, and it'll also act as a dual purpose of rinsing the product on top. It's going to take about 15 milliliters more. Yep. And try to get as much of this product as I can. Don't want to stain the new lab materials. And take a look at how chunky it is in there. Still need another recrystallization, but it appears to be the product that we want. So we succeeded in that end. Not very crystalline, more like a paint. I'm gonna go paint a masterpiece. A very orange masterpiece. That is some funky stuff.